is used in lifts, and they're used to, now they could be used more to reduce energy consumption and environmental impact, and thus produce better lifts. It's barely used these days in lifts, and but the number of high-rise buildings made of wood continues to increase, and it only seems logical, he says, to consider using wood for lift construction as well. At present, the increasing number of high-rise buildings in the world are being made of wood, and among them there are two types. Of the two types that I'm showing on this slide, the first is a wooden construction built around a concrete core, that's the left-hand one, and the second type, which satisfies purists even more, who prefer buildings completely constructed of wood, is this one here, which is 85.4 metres high, and is officially the world's tallest building. There's one there which is proposed to be placed in London. It's a building proposed by researchers from Cambridge University and PLP architects, and this is going to be a 300 metre high wooden building in London. Now the paper that Roland will be presenting is not talking about wooden buildings, but talking about using wood within buildings. And he says that the materials for wood needs some considerations, for instance, on strength. There is an EN standard 1995, Design of Timber Structures, Common Rules and Rules for Buildings, which debate the different characteristics of wood and the strength classes of wood. And you can see these hieroglyphics C14, C50, D30 to D70 up there, which didn't mean anything to me till I looked into them. And basically, if you look at that table, you can get bulk densities of wood from 410 to 520 kilograms per metre cubed in the range C35 to C50. That's the last four on the top there of the poplar and softwood species. But if you move up to the hardwood species of woods, you can get between 740 and 870 kilograms per metre cubed, which is considerable improvement. And this means that really only hardwood species come into consideration if you're building a building of wood in terms of the requirements for strength. Solid timber has a load dependence on the grain of the wood, and the strength decreases with moisture content, which is a problem. And he cites an example that if you change the moisture content of wood from 12 to 20%, it reduces the strength by 26%. So an 8% change in moisture content in wood reduces the strength by 26%. And the dimensions change as well. To overcome that on a pure piece of wood, plywood was invented 150 years ago, and that's with the interlaying cross grains that you got in it, was the first manifestation of these laminated wood products. And as a result of that, higher strength values were produced, the swelling problem and the shrinkage reduced, and this slide shows a number of different laminated type products that you can get. Glulam, the cross-laminated CLT, the LVLs, the laminated veneer lumber. And they come under different names. This Bobach Q is a name of a particular laminated wood. There are some special aspects to consider when designing with timber. The large influence is the moisture content, and this graph on the left-hand side shows you what happens as the moisture content increases. We've got German words all over it, but I think you can probably understand what that means. and it deals with the service classes which are in this lower table. Now, wood deforms more than steel when it's under constant load, and so there's a higher deflection of bending under load, and these considerations have to be taken into account in dealing with low duration classes when dealing with wooden structures. Now, there are some other special aspects to consider when designing with wood. Fire resistance. Wood is flammable. It does withstand fire for a surprisingly long time by the carbonisation of the surface and so on. And we make fire doors with wood, don't we? There's problems of gluing the things together with formaldehyde, other adhesives as well. Some of these are not really very nice for us humans. And then there's pests. Pests include fungi, insects, bacteria, which can cause difficulties with wood deterioration. Now, Roland is proposing making machine frames out of wood, and he shows two pictures. The left-hand side is made with this beech material, and it's completely made of wood. He somewhat abandoned that idea in the difficulty of constructing it by a second version on the right, which has got some metal. The some metal being mainly keeping the thing together by bolting it together rather than using wooden dowels and glues and things. The second version was preferred because it could be manufactured better than the first version. The design that's up there, surprisingly, and I can't actually work out the size of the thing, all I can see is these paving slabs in here, and experience of laying paving slabs would suggest that this is something like a metre long slab, and so that gives you an idea of the size. That particular version that you see there is for a 450 kilogram lift, running at 1 metre a second with one-to-one direct reeving, and the weight of the motor that is on the thing is 200 kilograms, and the machine frame weighs 100 kilograms. Of the construction, steel parts contribute 40 kilograms, and the wood contributes 60 kilograms. He makes the point that the low weight, he considers that to be a low weight, facilitates transport on the building site and in installation. And there's an important point, perhaps, and maybe the key as to why this particular session is with the other two erudite presentations on vibration, is that wood, unlike steel, has a lower tendency to vibrate. And so that gives you an advantage to that. There's some further information that he puts up here. The contribution towards reducing the environmental burden. And he's taken the Otis Gen 2 Stream Environmental Product Declaration as his example. And it talks about things I don't particularly understand, U1s and D4s, which are global warming potential and adiabatic depletion potentials. All seem to be very long-winded words for something, but basically he's saying that it is possible to improve the environmental impact because of using wood. Anyway, congratulations to Roland for producing this paper and allowing me to present it.